Welcome back to Chapter 5, Chemical Changes, Section 5.2, Displacement Reactions. By the end of this tutorial, you will be able to know the position of carbon and hydrogen in their reactivity series and how to predict displacement reactions, and explain how the reactivity of metals is related to the tendency of the metal to form its positive ions. Let's discuss now displacement reactions that are related to the metal reactivity series. You have now seen how to use the reactions of metals with water and dilute acid to get an order of reactivity, which you have already seen in the previous tutorial. Now, you can also judge reactivity by putting the metals into competition with each other. What do we mean by that? We mean that one metal starts off as atoms of the element and the other metal as positive ions in a solution of one of its salts. For example, you might have magnesium metal, which is Mg in a solid state, and copper 2 ions, which are Cu2 plus, in a solution of copper sulfate. And a more reactive metal will displace a less reactive metal from an aqueous solution of one of its salts. So if magnesium is more reactive, it will displace the copper ions and the copper will be released as a solid back again. In this case, in this reaction where we added magnesium into a copper sulfate solution, where it contains copper ions, which are Cu2 plus, magnesium is more reactive than copper. Therefore, copper ions will be displaced from solution to form copper metal. So the magnesium will kick out the Cu2 plus ions from the solution and will take their place. It will sit in place of the copper ions. And then if the copper ions are getting consumed, what is happening to them? They are turning back into its solid state. And in this reaction, the magnesium metal forms aqueous magnesium ions, which is Mg2 plus ions. And it will dissolve in the solution. This is what we call a displacement reaction, where magnesium plus copper 2 sulfate gives us magnesium sulfate plus copper. You see, the magnesium displaced the copper in the equation. And if we write the balanced symbol equation using symbols, we can write it as the following: Mg as a solid state plus CuSO4 in the aqueous state, it gives MgSO4 plus copper in the solid state. Magnesium, which is in green, it displaced the copper, which is in yellow, and copper was released as a solid. However, Mg now, it is in the ions form, which is Mg2 plus. Now, one thing to shed light on, which is the ionic equation. An ionic equation, it shows only atoms and ions that change in a reaction. So we have only the magnesium and the copper that we're changing. So that's the only things that I include in the ionic equation. Mg plus Cu2 plus gives Mg2 plus Cu. So Mg was in the solid state. It became in the ionic state. It turned into an ion. However, copper was an ion. It turned back into a solid. Magnesium atoms have a greater tendency to form positive ions than copper. That's why magnesium is more reactive than the copper. Another thing and note to shed light on is zinc metal. Zinc, if we're going to compare its reactivity to lead, zinc is more reactive than lead, which is Pb, and it is higher up the reactivity series. Zinc, if it reacts with lead nitrate, zinc will displace the lead, so we will get zinc nitrate plus lead. Zinc was in the solid state plus PbNO32. It will become zinc NO32 plus Pb as a solid.